Welcome to the electric vehicle simulation using Matlab. In this video, we will see the full explanation of each and every block, and we will see the state of charge and the running range calculation. So first we need to know the basic block diagram of an EV. So the first thing we need is a motor. Motor will produce some power and torque, and that torque will be supplied to the gearbox. So gearbox will multiply that torque and supply it to the differential. After differential, that torque will be transmitted to the tires through the axle. So we need to supply some power to the motor. So we'll supply that power through the battery, but we can't directly supply because that power will be uncontrolled, means we can't control its speed. So we need some controller. The controller will work on the basis of driver's input, means like throttle and the brake, and after converting that signal, controller will give that signal to the motor. So this is the overall block diagram of an EV. So first we need to decide our approach, means how we will go towards our simulation. So first block is vehicle body and the tires. So this includes our simple gear, differential, vehicle body and the tires. The second one is the motor and controller. In this our motor will be there and the controller will be there, and after that the driver input. So here we will use the different drive cycle or the throttle input by the driver. So without wasting much time, let's get started. So first we will open our Matlab. So I have already opened it. So first you have to go to the Simulink, and after that blank model. So this Simulink window will be open. As we have decided in our approach that first we will define our vehicle body and the tire. So by simply pressing the control and the dot button 2 times, we have to type the vehicle body. So this is the shortcut key, control plus dot. So what is this vehicle body? This represents the chassis of a vehicle, means the entire chassis of the vehicle. So here there are 6 ports. The first one is the normal reaction of rear. This is the normal reaction in front. This represents the normal reaction of rear wheels, front wheels. This beta indicate the inclination, means the inclination of the road, like gradability. H represent the hub. V is the output velocity of the vehicle, and W is the wind resistance. So by double clicking into the vehicle body, we can update our mass of a vehicle, number of wheel per axle, CG, gravitational acceleration. We can update the frontal area of vehicle, drag coefficient, air density and all. So I will take 2 meter square my frontal area and 0.25 as the drag coefficient, and will take 1000 kg as the mass of my vehicle. So after that we need tire. So we'll use this magic formula tire. So here are 4 ports. This is the normal reaction, this is the axle, this is the hub, and this is the output slip. So by double clicking we can update these reaction values. The geometry is the radius of the tire, rolling radius of the tire, and we can include the rolling resistance, which is having by default value of 0.015. So by simply pressing control and dragging it down, it will copy that same. So here we will first simulate the only 2 wheels which will represent our rear wheels. So we have to connect this H hub of the tire with the vehicle body, this hub to this part. Okay, so now we have to connect the normal reactions, this and to this. Okay, so here we have 2 axle. Now we will simply insert this simple gear. So this simple gear, so this is, we can update our ratio, means 2 4 like this, and the direction of rotation. So for getting positive velocity I will keep the same direction as the input shaft. After that, we have to include the differential. So this is our differential. I will quickly rotate this. Okay, so B is the input of the gearbox and F is the output. Here D is the input of differential. So I will connect this F to this D and connect this S1 S2 to the XL. So this is our XL. So this will be our connection. Okay, so now we want this output velocity, so we will use some display for observing our velocity in real time. For saving that velocity, we will use scope so that we can plot the graph with the time, but we can't directly connect to this because this is the physical signal. This velocity is the physical signal. We have to convert this into a digital, so we need some physical signal to digital signal converter. So we will use PS Simulink converter. Okay, so I will connect this V port to this. Okay, and give this input to this, connect the same. Now here we have to update our unit. So I want my velocity in kilometer per hour. So here the first part is our vehicle body and the tire is completed. Now our second part is the motor and the controller. So we will move towards our second part, which is the motor and the controller. So I will drag this to this side and I will use DC motor. Okay, this is brushless motor. We want simple DC motor, so use this one. So now this is having 4 ports. This is the positive, plus, minus supply. This is the output shaft. We will connect this R part to this P. So this is the output shaft of our motor. We will connect to the input of the gearbox. This C should be connected to the body, means it should be the reference. So I will use the mechanical rotational reference. Like this part will be grounded. So now we have to supply the positive and the negative. So by double clicking we can update the parameters of the DC motor. So we will simply use birated load and the speed, and I will take the no load speed as 6000 rpm, the rated speed as 4000 rpm, and the motor wattage as 5000 watt, means 5 kilowatt. Okay, so permanent type motor and permanent magnet type motor, and model parameterization by using rated load and speed. So now I will quickly give ground supply, means the electrical reference, to this negative of this motor. So now we have to control this motor. So we will use H bridge controller. So sorry, bridge. So this is our H bridge. Okay, so here you will see there is first block is of PWM, pulse width modulation. Second is a reference, third is reverse, and fourth is the break. This is the plus and the minus port. So we need PWM. So we will use this control PWM voltage, and here we will connect this PWM to this PWM. So now what is this H bridge and control PWM voltage? So in H bridge you can control the different port like brake, reverse, and this PWM is our acceleration. So by double clicking you can update like whether you are supplying power internally or externally. Means if you are using battery, then you have to use external, and if you are not using, then you have to use internal. So after that you have to select the simulation mode. So if we use average, it will reduce the time of the simulation. After that the input threshold and the bridge parameters. Okay, so we will update it later. And this is the PWM. So here is input. For 0% duty cycle the voltage will be 0, and for 100% it will be 5. Okay, so now we will connect this positive with this positive, but we have to measure the current of the motor. So we will use current sensor, and we'll connect this positive and the negative to this port. Okay, so now after that we will connect this negative with the ground, and we will connect this reference negative. We will connect we will do connection like this, and still we have not updated our brake line. So we will update two lines later, the reference plus and the brake. The reference plus is nothing but our acceleration input, and brake is nothing but our deceleration input. So for getting the current we need some scope and the display. So first I will include one scope here and one display. So we can't directly connect this to the this. We need some converter. So we'll use the Simulink converter. Okay, so this is nothing but our current. Display will show in real time, and this will generate the graph versus time. So after that, so our second part is almost complete. Now we will go towards our third part, which is the driver input. So we will quickly recheck our values. So first with motor, so 5000 watt, no load speed 6000. Now we will work with 48 volt system. Okay, so H bridge, as it is internal power supply, so we will give 48 volt from here itself. So for this we want solver configuration. Okay, so we will attach here. Okay, so this part is almost completed. So now we move towards our third part, which is driver and its controls. So we will use longitudinal driver. Okay, so this is our driver. It is having 6 port: reference velocity, feedback velocity, grade, which is nothing but our gradient, acceleration command, deceleration command, and information. So these are the main two outputs, and here in reference velocity we have to give input. So we can use different drive cycles or like throttle. So first we will include a multi-port switch, means we can easily shift between our input. So this is our multi-port switch, and I will also include the drive cycle source. Okay, so how this switch works? So default value of multi-port switch is 3. If we have to change, then we will use one constant. So this constant, if the constant having value 1, then it will be connected to first port. If it is having value 2, then it will be connected to second port. Likewise, we will keep it as 1. We can use different supply like signal builder, and even we can use different type of supply. This is nothing but our reference velocity. Okay, so now what is the feedback velocity? Feedback velocity is nothing but our velocity here. So this is our, the output velocity of vehicle is nothing but our feedback velocity. So here we will use gradient as 0. I will simply copy this tab, will connect and give it value 0. So now our main part is this input, this acceleration and this deceleration command. So this is having digital value, it will line 0 to 1. So first we need the Simulink PS converter. So we will connect this to this, we will copy the same. Now we will use the control voltage source. So there are two controlled voltage source. One is this one and one is this one. So here we want this blue one. We'll use this letter. So we will give. So now what is this control voltage source? Whatever the voltage through this port, through this triangular port, it will provide the same voltage throughout the circuit. Means if I connect this positive to this positive and this negative to this ground, then whatever the voltage is here, it will provide the same voltage throughout the circuit. So this is nothing but our control voltage supply. We will simply copy this and we will use same for our brake. I will give positive to break, negative to ground. Okay. Okay, so now if you look, this values this value will lie in between 0 to 1, but if you look in PWM, input scaling is between 0 to 5, so we have to change this 0 to 1. We will change the output voltage to 1. We'll change this, let me change, so this should be average. Okay, this should be average. 0 to 1, 1. After that we will change this input threshold. Let's change the, okay, and we will keep this voltage as 48 volt because our system is 48 volt system. Okay, so now this part is almost completed. We have included the solver, so like, so we'll quickly run this. So this is 2474 seconds. We'll run it for first, we'll first run it for 10 seconds only, and then we'll check. So it will take time. Okay, so let me check, is there any value here? Oh no. So we'll change this to 1000. Let's check. Let me check. So now we are getting the velocity. Okay, so we want to know our input velocity as well, means the drive cycle. So we will simply connect one port, we'll add one port here, and we'll use the input from here. Okay, so we have to change data from here. Okay, only the driver. Okay, so we'll change to kilometer per hour. Okay. So let's run. So this blue one is nothing but our drive cycle, and this is our vehicle. So it will depend upon our weight and the gear ratios. So the reason behind this deviation is we have not taken the optimized value. We have taken the random value for power. We have taken the random mass, random frontal area. So this kind of error will occur. So now we'll check this graph like this. Look at the profile of this yellow graph. Now we will optimize it. We'll just do some adjustment and check. So now look at the profile of the graph. So it is lying on the expected graph, but the top speed is not matching because our ratio is more, reduction ratio is more, and the motor RPM is less. Let's look at uh, this profile in between 0 to 100 seconds. It is almost on the expected line. So we'll increase its motor's RPM. So suppose I will take here 10,000. Will run. So till now we have not considered any battery. Means we have taken the internal supply from edge bridge. Now we'll look to the graph. So now look at this. We are achieving the top speed of 80 kmph. Okay, so we'll keep this as it is.